Hi, I'm Lando and this is Kinesis, a channel about my personal game development adventures. Today I will be replicating the throwing mechanic present in Pokémon Go using Unit, and the entire source code will be available for free in the description. Okay, so let's analyze and split the entire mechanic into a few steps, so we can better visualize what you will have to do. First, the user can touch anywhere on the screen and the ball will immediately stick to the pointer's position. If I move my finger, the ball should follow. Second, if I do a circular motion around the ball, it should rotate accordingly. With enough speed, it should activate its curveball mode. Third, the throw itself. Based on how quickly you move the ball, it should go forward at relative speed. If the curveball mode is active, instead of going straight forward, the ball will do a curved motion. Also, be aware that if the motion is not fast enough, or if the motion's direction is to the bottom of the screen, the ball should return to its origin position. And lastly, the ball will collide with either the Pokémon or the ground, and they should have different behaviors. Let's get to it! As I like to do my projects, I started populating it visually to warm up my brain cells and get inspired. So I got a Pokéball, which I downloaded on other resources from Pokémon Go itself. For the environment, I wanted to look like a forest, so I went to the Creative Trail website and got the stylized trip pack, which they make available for free. For the Pokémon, I could have been to model resources again and downloaded any model, but they would be in their static T pose. Instead, I got this kawaii slime pack from Unit's asset store and chose the one with the crown. I also wanted to give it a toon look, so I went to Unit's asset store to search for one, but none of them worked with URP. Instead, I went to GitHub and got this one called Nilo Toon URP. Next, I searched for a grass texture and a dirt texture. And finally, I stylized Skybox, which I also downloaded from Unit's asset store. They have some variations, but I liked this one more. And this is how it turned out. I think it's good. So let's start doing some code now. Just one note before starting, I refer to both mouse and touch as pointer, keep that in mind. I put a collider in front of the camera and casted a ray from the pointer's position to the camera forward direction. The collision point is where I want the ball to stick. I don't want it to happen instantly though, so I added a code to make it smoothly follow instead. Alright, first point check. To do the rotation though, I would need some math, and to be honest, it's not one of my strongest skills. What I know is that I have two vectors, the one from the ball to the pointer and the other which is the pointer delta movement. I was sure that I needed to do something with them. I went to Freya's Discord channel to ask for help and very promptly Freya herself gave me the answer, which is the cross product of those two vectors. I put the formula into my code and it was working exactly as I wanted. It was rotating infinitely though, so I just added some angular drag in the ball's rigid body. Alright, second point, check. The next step would be the throw itself. As I mentioned earlier, I have the pointer's delta movement. I just need to convert from 2D to 3D, pointing forward. However, just using the last delta is not ideal because it's too unstable. Instead, I used the average value of the last 10 frames. Check the difference. What to do with this vector though? My first attempt was simply passing it as a force impulse, but the physics was not feeling good, and I would probably have a hard time doing the curve as well. Instead, I decided to use a Bézier curve and make the ball follow it. Also, it would be super easy to make a curved throw with this technique. On this topic, I can't recommend enough the video The Beauty of Bézier Curves. It is a masterpiece made by Freya. Anyway, my first implementation was using a simple interpolation, but that's not ideal because I would have to position the endpoint always on the ground. It's not reliable enough, that also makes a weird trajectory. Instead, I extrapolated the final point using an unclumped linear interpolation. With that in place, I just needed to make the ball follow it. Okay, it's not there yet, but I just need to tweak some settings.
Moments later.
Oof, it was harder than I thought to get the feel of it, but after some adjustments, this is how it's looking now. I think it's decent, and you may notice that the balls are colliding, which brings us to the last topic. As you know, I am not using physics to throw the ball, so I had to fake the collision. Whenever the ball overlaps something, I stop following the path and enable gravity. However, that's not enough. To make it feel right, I would also need to apply some force and simulate a bounce. To do so, I simply stored the previous ball's motion, got the collision points normal, reverted this vector and applied it to the ball. You know that it's fake, but it's pretty convincing. Alright, last point also checked, but I think we have some room for polishing a bit. So I did one particle effect for the ball when it's rotating and also added one rotating sprite. When the ball is thrown, I am enabling a trail following the ball's position. Also, I did one particle effect of leaves falling and another one for these little dots appearing here and there. I think it's a nice touch, and this is the final result. Please let me know what you think of it and if you do something different. I'm sure there's a clever and better way of doing all this, which I would love to know. Anyway, I hope you enjoy it somehow. As I said in the beginning, the source code of this project is available for free on my GitHub page. The link for testing it out and for the repository will be in the description. Please let me know if you use it for something, I will be super happy. See you in the next one. Bye!